and good morning, folks, and welcome to a slightly different live stream I have for you here today. What we're looking at is the Toyota Gen 3 Prius, that is Gen 3 inverter converter. And what we're going to be doing is doing some reverse engineering on the logic and IGBT driver boards to see if we can design a replacement for this Toyota logic board to let us use the hardware, so the power stage stuff like the inverters and the converter, DC-DC converter and all of that fun packed stuff. So our mission today is to basically work out as many of the signals here, particularly on this little 50-way cable, to see if we can determine how to switch on the IGBTs, control them, interpret fault signals, read the current sensors, read the temperature sensors, and all of that fun packed stuff. So that is what we're going to be doing. Basically, I'm just going to work away as I would normally. So this is going to be probably quite a long duration video with kind of lots of things with nothing going on. So that'll be just the nature of it. But feel free to jump in and ask me questions and things like that, and I'll take a look at the computer now and again and do my best to answer. And additionally, if anyone has any suggestions as to what I should be looking for here, then please do jump in and leave me a message. So, alrighty, I'm just going to go for it then. So one of the first things that you tend to do when you're looking to reverse engineer something is to do a little bit of research first. So one of the things I did is I looked up the Toyota wiring manuals to see if I could find out any pinouts for this multi-way connector here. And I'm not looking for all of the pins and all the things that they do. I'm basically just looking for power and ground, because it's much easier to determine how things work on a board when there's at least some power going to the various components, integrated circuits, all that kind of thing here, than if you're just trying to passively analyze it. So worked out the power and the ground here just before coming on, and yeah, so we're going to connect up 12 volt power, which I've already got here with just some cables, and we'll pretty much turn this thing on and start working our way through it. Now, another thing that's worth keeping in mind is that you don't need tons and tons of fancy expensive test equipment for this. I'm just going to be using a basic multimeter. I have a simple oscilloscope here as well if we need to do some more advanced signal tracing, but other than that it's going to be really just more using observation and looking for patterns, because there'll always be patterns in any kind of a circuit, particularly, you know, automotive stuff, automotive power electronics, and that will tend to have patterns in there that we can identify, and they will then hopefully lead us to being able to work out what was in the mind of the designer during the design process. Now, some boards give you some useful information on the silk screen. You know, you get something that will say a plus 5 volt test point or a plus 12 volt test point or something like that. At first glance, our Toyota boards don't seem to do that. The only useful thing that I can spot here on a first look is where the actual IGBTs connect to the IGBT driver board. There's some lettering here: E2, S2, G2, A2, K2, E1, and so on to S1, G1, A1, K, and K1. I'm going to take a guess that there might be a temperature sensor built in here as well. Now, I went ahead as well and looked up some other documents. And we've got here is the kind of a general picture of what goes on. So this, and the one in the middle, is our MG1, and this is our MG2. So I'm going to just get a marker. I'm going to just mark on the back of this plastic MG2. It's called the motor in the documentation. And that's MG1, just so I can look at a glance here. So alright, I'm just going to jump straight in. As I said, anyone who wants to participate, please do. Otherwise, I'm just going to crack on. Alright, let's get some power on this thing. Alright, so I got power on here, and first thing that I'm hearing is an audible whistle. I don't know if it's going to be audible on the microphone, but it tells me that some of these switch mode power supplies in here must be powered up. So that's a good sign. I'm also drawing 1.13 amps, so notes are your friend here when you're doing this stuff. Now, so I'm going to switch off the power. I'm going to disconnect this ribbon cable from the IGBT driver. The problem with these little connectors is you got to try to pinch the two sides at once, which can be quite tricky. I'm trying not to rip it off the PCB because that would be really bad. And the good news is, this is also looks like being a JST connector, so it looks like something that we can physically buy. So, alright, so powering up with just the logic board connected, and these guys here, admittedly, are at 516 milliamps. So we'll say, this it's 516 milliamps. Alright, I'll go ahead now and just unplug some of these, see if they cause any current drop. None on that one. Oh yeah, that's dropped a bit of current. There's something here. Let me disconnect this guy. And from 516, 456. 456. And MG1, I'm calling it the current sensor. Disconnected. Don't know if it is a current sensor yet, I'm just taking a guess on it. I'm also going to do the same thing with this one. Yeah, we dropped about another 50 milliamps. So there's something in these two that are using power. Okay, that's interesting. So with everything here disconnected, I can do a connector over here. That doesn't do anything, probably just a little current sensor or a little temperature sensor. I think, yeah, just a little temperature sensor connects over here. So just the logic board on its own. Hang on, there's something else here. No, and just alright, so logic board all on its own is taking 400 milliamps. Alright, let's shut her down. Let's reconnect everything. Now, our little JST plug does have pin numbers on here, so let me. Looks like they've used all JST stuff, which is good news. So I can see the pin numbers. There we go. Okay, this is pin 2. Okay, I've got pin 2 to pin 50 on this side. So it looks like I have a blue wire on pin 1. Quite make out this one, but oh, okay, so they're all blue on the back. So looks like this is pin 1 here. So looks like it goes 1, 2, and so on. I don't know if I've counted this wrong because I think it says 67 on there. Sorry, 49. Yeah, 49 and 50. Okay, so it basically counts 1, 2 from back to front. Try to keep that convention. Now I don't really want to unplug that guy too many times. Those plastic connectors don't generally last very long. Alright. So 1, 2, 3, 4. So we go for 1, 2. So 1, 2, 6. And 49 and 50. So just made a little rough connection diagram here, and go ahead now and start looking at what voltages exist on here. That we're going to use our simple multimeter. Alright, so 20 volts DC range, got one end of it connected to a good ground, and I've got a fine tip probe on this end. So let's go for alright, we're back up on high current. So probe across the back here first of all. Now you also want to make sure that you get a good connection. So I'm going to do in this case is grab that little magnifier so I can see a bit better in here. And basically, yeah, that should be better. I'm going to turn this around. Alright, so this is pin 2, 4.45 volts. We'll work along this side first of all. Next one, minus 5.06. So call that minus 5 volts. We got 0.5 volts on this pin. Another heavier track going to this one. 5 volts.
Next one. 0. So, heavy track with 5 volts. Two zeros. Heavy track with 5 volts. 0, 0. Now 4.46 on the next one. Another heavy track here. It's like a ground.
You can spell out any, we believe, are grounds.
Next one, 4.47. Zero. Another 0.
Let me just make sure my count is right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So
1, 2, 3, 4, 5, 6, 7, 8. 10 is 0. And next up,
another 4.46.
Zero.
Check out my left-handed writing.
Very good, I'm afraid. 4.46.
And 0. We're already seeing a pattern here. 4.46.
Now the doubled up track here,
That's not 0.
It strikes me being a possible ground. And my next one is 4.98.
Wow, I really can't write.
It's not left-handed. Minus 0.07.
It's actually would be quite an interesting signal.
Again, everything's got a pattern. Minus 0.07.
Minus 0.07.
Next
One is minus 0.07. Patterns.
Good pattern recognition. So,
Now this could be many things. It could be a ground, a series of grounds, or slightly lower than the meter ground that I have here.
same again.
This one is the same.
And finally, last pin up on this, which is pin 50, which is a heavy track, and is currently reading 0 volts.
One, two, three, four, five, six. Oh, isn't that interesting? There's 6 those signals there. So now we need to do the far side. Probably the best way to do the far side to be to try and get in on the back of this plug here on the actual IGBT driver board. So that's what I'm going to try and do. I'm just rippling the probe along there just to see what the meter does. There's some interesting voltages there for sure. So I'm going to try and move some of this junk out of the way here so that I can probe with my left hand and probably write with my right. Otherwise I won't be able to interpret this crap when I actually get there. So get to interpreting what that is. So alright, I've got 0 volts on this one. Zero volts. Minus 0.06. Minus 0.06. 0 volts. Minus 0.06. In fact, I would dare say that all of these are going to be on this. 0.06 volts. Ooh. This is an interesting pin. 13 volts here. Okay, no I don't. I think I've screwed up mostly. I think I've done screwed up wrong. Fortunately, there's no one to see me. Woohoo! Then I bet you I get an email or two today. Damien, how do I reverse engineer something? Wow. Watch this boring live stream. It is guaranteed to be boring. Alright. That's 1, 2, 3, 4, 5, 6, 7, 8. 8 is 13.2. Got 8 is 13.2. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 13.3. Which is, kind of what we're supplying to our card here. So straight away, that's a very interesting. That's a power supply pin. Let me just adjust the power supply voltage a little bit, and you'll see if that varies. Yeah. So that's straight connected to the 12 volt input. Ah, crap.
2, 3, 4, 5, 6, 7, and 8. Oh, I'm wrong again. Okay. Okay, the next one is the same. Next one is the same. So probably it's going to double up on some of these pins. 13.2. What the heck? Yeah. So I can see 4 vias are down through here. 13.2, 13.2. Okay, I should have 4 13.2s there. Yeah, I do. So, alright, next up is the zeros. Zeros. Rivals. Rivals. Anytime you see voltages like this together, usually means our power supply. .46 again, there's that mysterious voltage. And I have to say hello. 5 volts. .45. Minus 5.1. I think I managed to miss more than I've hit here now, because that's actually the last pin there, which is 4 point. Yeah, I've screwed up here, alright. 1, 4, 3. That's okay, it's kind of a scratch pad type of a thing. So we gotta kind of just work our way back up along here. It's kind of difficult to get in there. I could make life easier for myself if I took this off and flipped it over and stuff like that, but I don't really want to do that just at this point, just yet. So let's see, then I've skipped over a few. Definitely know we're right here. Get my little magnifier out here. That's really getting a little bit overheated. Wow, this is the best time to do live streams. Nobody bothers me. It's great. Alright, now. Let's see. I can get in here a bit better maybe with the glasses, but maybe not, because it kind of doesn't let me get in there as close as I need to be to use them effectively. Actually, yeah. Here, I wonder if I could actually get in here. Take this around a little bit and just go from here. Yeah, I can do that. Alright, so that's 0. -06. So I've got 0. And 0 on this, I've got -0.06. Oh, that's that pin. So into the second pin here is 0.06. Third pin, 0.06. Fourth pin. There's actually minus 0.06 as well. So we have that one. Here minus 0.06. Right, the next one should be the same. Yeah, minus 0.06. Okay, so up to this point, I'm now correct. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm correct here. Oh, I'm skipping one. 1, 2, 3, 4, 5, 6, 7. Yeah. Alright, so up to there, I'm correct. 1, 2, 3. Let's see if I can work my way up from the bottom now. Get a little bit of extra light in here. Let's just use this in the light. Here we go. Yeah, let's see if I can just use that as a light. Okay, so the bottom one is actually minus. Yeah, that's weird. Hang on. What's going on here? Whoa! You're doing something squirrely on me here, guys. You're doing something squirrely on me in this cable. Flipping pins over or something like that. There's a pin, bottom pin here at 4.42. And go to what should be the same pin here. Oh, 4.42 as well. Okay, that's not too crazy. Okay, so 4.42. Next one down is a heavy track. Minus 5. Now the heavy track minus 5. Minus 5 heavy track 1.3. 4.44. This pin is 4 volts. 4.44, and I have another 1, 2, 3, pin 4. It's 5 volts heavy track. Also the same on the opposite side, so that's another pattern. Okay, so 1, 2, 3, 4. Five is also plus 5, so I've got a 5.01. Value there is 4.44. Here. So 1, 2, 3, 5 is 4.44. Also on a via 6 ground. So well, 1, 2, 3, 4, 5, 6. 0 volts HT. I'll call it for heavy track. Also ground. Ground, sorry, don't mind me, I'm saying ground. I should be saying 0 volts. Doesn't necessarily make it a ground. Ground does not make. 0 volts does not a ground make. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Here comes number 8. 5 volts. So I'm going to tick this here because you know this is correct as far as 1, 2, 3, 4, 5, 6, 7, 8. Over just 8. All this 1, 2, 3, 4, 5, 6, 7, 7. Just little annotations like that. So 1, 2, 3, 4, 5, 6, 7, 8. And here comes 9. Next one is 5 volts. So this one, 5 volts. And beside it is 5 volts. So that one's 5 volts. Beside him is 0 volts, which is correct. We'll tick that as being correct. 0 volts. So say 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. So 8, 5 volts. 9 is 5 volts. 10 is 0 volts. 0 volts. Correct. 11. 0 volts. 0 volts on the pen. So it's 8, 9, 10, 11, 4, 5, 6, 8, 12. Also 0 volts. 13 volts. So 0 volts. Tick 8, 9, 10, 11, 12. I'll try around now and come at it from. I'll try and come at it from this side here. I'll get a little cable tie. Just pinch him in a bit with it. Just to give myself a little bit more working space in there. Go. Okay, so that's just going to peg that in there a bit. So 7. So we've got a little bit of heat generation here, which is good if we track that as well. 1, 2, 3, 4, 5, 6, 7, 7, which is minus. Okay, so 8, it's 13. It's correct. 13. Alright, so let me see if I can get my pin in here. 8. There's 13. 13. 13 and 13. Is it 13? Yeah, I got 4. I should have 4 13s, so I should have 13, 13, 13. And this one should be 13 as well. 13 volts, so bringing me to 7, 8, 9, 10, 11 being correct. There, so only needs me now 2 in the middle here till we join up. So I got a 13. Damn, it's a little tricky. Let's see here. It's a little bit more light now. I'd be just laughing. Just see if I can use this again. Alright, let's gonna use this as a light. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. So that's 13, 13, 13, 13, and the next one over here, also 13s, 5 13s. I'll be able to verify some of this with our next trick as the saying goes, but okay, so let's see. Alright, so I got down to 12 here then. It's 13. That is one in the middle. I'm not sure about. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is a hot above the end there. Let me see if I can get in from this side. It's hard to get the light really in there, so it means. Also 13. Also 13. Alright, so it looks like they're all 13s then. So I got a 13 here on this one. Middle here of the ground. Alright. So what we got now is got a little bit of confusion going on because from the looks of it, we've got a bunch of 13s here. 1, 2, 3, 4, 5, and possibly 6 of them. Possibly 6 of them here. So I'm going to put this in as a 13 as well. And what we'll do is then we'll disconnect this guy. We'll actually see what goes on there. Alright. Now, so the next step in our cunning plan, we'll switch off our power supply. We're going to disconnect our, disconnect this here for a sec. Again, I'm just trying to use this pliers just so I don't damage anything on here. Maybe it's a bit of a foolish idea, I don't know, but it can be rather tricky. I'll get rid of the cable tie just in case it's putting a little bit of strain on things. Sometimes I wish the internet would remember that I'm just one person. Just one guy, guys. Just me. Alright, let's switch this thing back on. Now, next thing we want to do, see if some of these suppositions about our 13 volts are correct here. Okay, so it's gone up a little bit because we're drawing less power. Obviously, that makes sense. So what I want to do is I want to come down here and say, okay, so 1, 2, 3, 4, 5, 6. Now I can just see straight in here. So it's a ground. Interesting. You can determine a lot by just looking at how the voltage changes on things when you disconnect certain parts of the circuit. So there's 3, 4, 5, 6, and 7. So that is correct. 7, and next up now is 8, which is 14. 9, 14, that's 2. 10, 14 is 3. 11, 14 is 4, so it's 11. 12, 14 is 5. So let me just take this here. And finally, this one. Well, 13, 14. 13 is right. I'm going to go down. The next one should be a ground or 0 volts. If I'm reading this correctly, and it is. Okay. So I should then be 0, 0, 5. Let's see if that's right. 0, 0. Okay, it's not giving me a 5 here, so that could be being generated. So 1, 2, 3, 4, 5, 6. Sorry, 0, 0, 0, 5. Yeah, that is correct then. So there I was on my last 13 here. I should be then 0, 0, 0, and 5 volts. So that's correct. It should be down 5 volts and 5 volts. 5 volts and 5 volts. 0, 0, 4.44. Yes. And here, the third. And 5 volts on the heavy track. 4.44, which is now gone. Very interesting. Minus 5 volts on a heavy track. Yes. And finally 4.43, which is now gone. So these are coming from 4.43s. Come from driver. Okay, so they come from the driver board. Interesting. Okay, so we now have ourselves a little bit of a pin map here. So it looks like the power supplies that we need are fairly straightforward. Looks like normal 12 volt supply and plus and minus 5 volts. So, interesting. Alright, next part of the plan. When we shut off our operations, I'm going to determine if any of these are actual ground grounds. So, to do that, put our meter onto continuity test. Okay, so I've got a continuity test on some of these
connections here. Some of these ground planes, we've got good continuity. Alright, so let's start on this side, just from the logic board. What I'm going to do straight away is just ripple. Okay, so there's some grounds there, and there's grounds on the far side as well. So, alright, here we go. 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. 20 is a GMD. Where's my pen disappeared to? It's 20. So in this case, it's actually this pin here. 1, 2, 3, 4, 6. Pin 6 appears again. 1, 2, 3, 4, 5, 6. G, M, D. Heavy track, ground. Next one. Oop. No. 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 So, got one ground on this side, which is our heavy track ground. Flip over. Now let's start up here at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 and 10. These ones here are actual grounds. G and D. These guys are grounds. That's ground, not ground, ground, not ground, and then ground. This is also GMD here. Here is ground. Next one, not ground. Next one, ground. What do you know? Look at this, another pattern emerging. Ground signal, ground signal, ground signal. Keep them side by side. So, ground, signal, ground, signal, ground, signal. And one more would be for look, ground. Ground, signal, and ground. This is the heavy track guy here. GMD. And signal. And ground. Yes. Signal. Okay, so we got ground, signal, ground, signal. This one's a ground. So now I should have, sorry, 1, 2, 3. I should have the ground. It's got the heavy track 5 volts but ground here on this one. So I'm getting confused now. 1, 2, 3, 4, 5, 6. Let's count up 6. 6 ground. Okay. Ground, not ground, not ground, not ground, not ground, and not ground. Okay. Let's have a quick look then and see what we can ascertain. So on this side, a total of 1, 2, 3, 4, 5, 6 grounds. So we have a total of, we take these 4.46 volt signals, we should have a total of 1, 2, 3, 4, 5. Well, We took that one. 1, 2, 3, 4, 5, 6. Okay, I would say we're well on the way to identifying most of the connections on this guy here. So the next thing we want to do is we're going to go and identify this connector here. And, what do I think we are next best bet? So I'm going to jump on the computer, do a little bit of poking around, see what I can find. Get something that looks like it's a match for this. I'm going to have to get that ordered then, so that we can start looking at, that's about the only one I can't identify. These are JST, but we know these from our Tesla logic boards, so they're simple enough. So it's going to be this guy we need to identify. So I won't really be able to put signals into this. Well, I can. I could hack into this here. I could probably pin into the back of it. It's a pain in the neck. We're probably better off to make a breakout board. Then we could connect to this. Just put various signals in here. So I think that's what I'll probably do. So I'll probably design a little breakout board to just that we can plug this guy into. Inject some signals in there. I want a little bit of looking around at some of these chips then. Okay, so let's go and have a look at that. Not the nails washing. Right. Let's see what we've got here. Let's tend to find Farnell are the best for finding connectors on. Alright, so there's Farnell. Let's have a look here. Look at a general Google image search as well. Let's see what we can find. Actually, well, let's go back to Farnell. Connectors. Wired board connectors. So we're going to search, first of all, we'll do JST. Don't really know the pitch, so we'll ignore that for the minute. And select 50 contacts, there's only 4 on Farnell. So let's see if that finds for me. No, this can't be that easy. Alright, so there's 4, looks like there's 4 connectors Farnell have in stock. Well, actually, no, I tell a lie, there's only 2 they have in stock. Or they actually say it's BM50. So what it is when it's just a multiple. Alright, let me have a quick look and see if that looks anywhere like what we're looking for. I think it is. I think we've already found it. Unbelievably weird. No, I'll tell you no, we haven't, because this one has a little piece in the middle of it. So that's actually not the one we're looking for. Unless they've just got the wrong picture up here. Let me pull up the data sheet. Pull up the data sheet. No, it's not an SHD, is it? That one would have been too easy. Okay, well, let's see what else we can find then. For JST 50-way. A bit of an image search here. Oh, I hate connectors. JST 50-way. Put SMD in there. That doesn't help me. I guess, the really annoying thing is this is actually known. There's people out there that know this stuff, but as usual, they just, 50-way. Board. I actually have to, unless we could try Mauser. Might be a good idea. Let's see what we can find here.
connectors. Connectors. Hard to know, isn't it? I/O connectors, headers and wire housings, edge connectors, desolved connectors, pin and socket connectors. Really hard to know, isn't it? So here what I'm going to do, I'm going to look at that JST part. I'm going to throw that part that I know it's the wrong one. I'm going to throw it into Mazda because it might narrow down where we actually want to be searching. Gives me the Molex part number. So headers and wire housing. Okay. So for our manufacturer. Right. Great. That won't be too easy. Okay, so, wow. Wire to wire. Added insulation displacement connector. Might be. Wire to board. Try it. So I don't really know the pitch. I can probably measure the pitch. Get a picture, maybe the best way to identify it. Certainly not. Certainly not 2mm pitch. Let's see if I can get my little vernier and see if we can measure the pitch. So let's see what we've got here. Looks like about 0.8. So we're going to see if it would be 1 mil pitch. Could well be it. Let's try 1 mil. Yeah, it's 1 mil pitch. Yeah, it's 1mm pitch. 1mm. Full metal jacket. Let's see what this guy is about. Nope. Nope. Of course not. That'll be too easy, wouldn't it? What's this one? Yeah, solar connector. Nope. Excellent. It's kind of similar, but the wrong one. I wonder if there's any other identifiers on there. They usually aren't. It usually just gives you the manufacturer, which we already got as being JST. Yeah, you won't really find anything else in there. Yeah, they are an insulation displacement, I think. Can't really tell.
This is always the part I hate the most with some weird connector. But I suppose we should be thankful that at least it's at least it kind of once is a normal one. It's not like the BMW ones you can't find at all. Try here again. No, it's not a CS connector anyway. What's this one? SH. No, it's not an SH, but it looks very similar to it. I actually don't think it is. Let me have a quick look at a die sheet here. Yeah, this is all too simple. I think there's one with the kind of bump in the middle of it. What is SHD, I think was. It's that one. Well, what's this one? Would we have a winner? No, we don't have a winner. Similar, but no cigar. It's this one, St. John. Nope. Wait. Think we have a winner. Think we have a winner, folks. Let me see here. Yeah, I think we got him. It's an SHLV connector. Now, wire to board connector, a high frequency transmission, blah 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 blah. Okay, so it's 1mm pitch. Yeah, looks like this is exactly what we want. There's the pins, circuits. I don't know. If we have a look here, because it looks like there's only 21 circuits on this one. SHLV. Definitely looks like the one we want. It definitely looks like the one we want. But well, here's a 3D down here. 21, 31. So it looks like there's only. Oh boy. Never easy, is it? SHLV. Can have radionics here now, but nope. SHLV. Oh, here we go. Yeah, here we go. This looks very like what we want. 31 way though is the only size we seem to have. That's 0.5mm pitch, so that's incorrect, but it is exactly the kind of connector. Just don't have one with 50 circuits in it. So what I'm really worried about is this a custom component that JST make for Toyota and of course don't sell anywhere else? That would be wonderful. I'm going to go back here and have another bit of a search around.
Open JST. Number of contacts 50, and then 4 again, which is not a good sign. Yeah, 1mm pitch, 50 way. HD, yeah, it's not looking good, guys. Yeah, I'm still on one again. Okay, well, let's assume then that we've got the wrong one, possibly. SHLV is kind of good, but no cigar. In terms of the number of contacts, double row. Here's a double row. SHLV. Search by connector feature, product guide. Oh. It's not really a ribbon cable, that. Let's see what else we can find out.
Thank God nobody's watching this. I'll just pop that slightly back in there. I'm not going to clip it down. Just want to move a little bit of that. So. Ooh, have I been a moron? No, it says HJST. That's interesting. UA over there. HJS2
UA. Should be just a day code or something like that. Connector JST UA. Show something. That's just junk. Alright, well, we can search by pitch in one way. Mode of connector. 1.25 or something like that. What's SHLD? Is that SHLV? It's SHLD. What's this? How many circuits does this one have? Oh, we have a 50-way. Oh, I think we could have them. Okay, I think we have them. With secure lock type, I think this is the housing, shrouded header, top entry type, side entry. Okay, here's the top entry. I think we've got it, guys. Let me throw this part number in here and see if we can get it from somebody and confirm it. DigiKey have it, looks like. Check Mauser. We'll go on Mauser. And DigiKey have them not in stock. Of course they don't. That's a 40-way, although they've helpfully decided to select for me. Alright, let me write this down. I'm pretty sure this is what we want.
Alright. Really boring.
Good job, no one's watching. Thank God. Right. So the top entry shrouded header is BM50B. BM50B minus SHLDS. S minus G minus TFT. There we go. Right. So, I want to go shopping, Mr. JST. I need that connector, Mr. JST. You will provide it for me. It is your job to provide connectors for me. Ooh, the JST shop. Right. We need the BM50B. Here we go. BM50B. What do we say? BM50B SHLES G TFT. There we go. That's the one I'd like, please. Oh, what an OS spring for 10. Purchase. Okay. Is it in my cart? Guess it is. So, quantity per carton, quantity per box. Right, why do I get the feeling that, so I can have a box of them, you can have 1,400 of them. Let's see how much 1,400 of them will be. Oh, it's a steal at 807 euros. Wow. Okay, let's not do that one. Fun in the sun. Okay. Wow. It's never easy with connectors. There'll always be something to ruin your day. Let's try Farnell just for a laugh. Nope, didn't think so. Remove some of those pesky. Nope, Farnell did not carry it, so we can forget Farnell. Let's try radionics just for another laugh. Actually, they don't carry it. Not even close to carrying it. Friends of Mauser, who usually be my go-to guys for weird stuff, they don't carry it either. Let's remove some of those pesky requirements, and they still don't carry it. So 807 euros, guys, for a box of 1,400. And the great thing is, we're not 100% sure that it's the right one. So, okay. No, I don't know. I'll search only for the 50, if that's okay. Thank you very much. Jeez. Octopart. Who are Octopart? AliExpress. Might have to. EVG.de. You might have it. Otherwise it looks like we're going to have to go AliExpressing here. And they're just some random into the EVG shop. Mechanics for electronics, electrical engineering. Yes, product finder. Find that product. Item not found. Excellent. So, AliExpress. $12 for a lot of 10. Sorry, this item is no longer available. Of course it's not. Let's do a general AliExpress search. No, no go. Wow, this is great. This is absolutely brilliant. How about side entry one, guys? Maybe we could probably make that work with a custom board anyway. So let's try the side entry type. For a laugh. For a laugh, right? For a laugh. DigiKey. Arrow. Well, it's been a while, but you know, an important storm and all that. And DigiKey have none in stock. Thank you, DigiKey. Check lead time. Let's do that. Oh, the 5th of April 2019. Great. This is why I hate connectors, in case anyone didn't know. Connectors are bad. Connectors are poop-lop. God, they're still all that. This is the most useless live stream in the history of YouTube, I would imagine. Let's try AliExpress for this one. Nope. No. There's been an error. Oh no. Wait now. Who's Arrow? Does Arrow have any in stock? Free overnight shipping. My God, guys, wait a minute. I think Arrow has it in stock. That's the right angle one, but it should still work for us. Now, so, yes, looks like Arrow are here to save the day with the right angle one. Now the question is, will Arrow sell to me? There used to be in these clowns that they wouldn't. There are 232 parts in stock. We just pull the data sheet, make sure it's the one we want. Yes, it is. It's the right angle one, but we can live with that. I don't know, I had a chance maybe, or I thought 5 maybe. Okay, $20. Let's buy that. Oh no, there's been an error. I'm not surprised. Increments of one piece. It says in stock. It says. Oh wait. Let me try again. This action could not be completed at this moment. Please try again later. Yeah, that's exactly what I thought, guys. There's always a problem. Connectors. Always a problem with connectors. It just is. It's just one of those things. Trying to find somebody who might deign to have one in stock would be really wonderful. Good thing is wait a second. My old Google image search might find something. Very easily, I just don't know. Right now I'm going to try anyway. Absolutely anybody. Let's see if they have one of these. Now, who are these guys? They are. That's a 40-way one. Yeah, 'cause that's really what I wanted, you clowns. Wow. Okay. Yes, I accept your fancy cookies. Okay. Con header shield 50 position.
I'm watching my part number now. It's BM50B.
Yes, this is obviously the different, yeah, this is a different component of our famous. Here we go, BM50B. Oh, this is a weird one.
SHLDS.
SRDS. What's the difference here? Yes, I want to open this snakehead. CHD is just a general purpose blob data sheet. Top entry type with a boss. Do we have a boss? Our one doesn't have a boss, does it? Let's have a look.
Top entry with a boss. I don't see a boss. Whoa. I'm wrong. There's a boss. We're doing it like a boss, guys. Yes, there is a boss. My one has a boss. Doing it like a boss. So that means then it's like a different part number that maybe somebody might actually freaking well have. So, what a boss is top entry BM50B. 50B S or DS minus A minus G minus TF. Like a boss.
Right.
Like a boss.
So let's try this one. Yeah, my one has a boss. Now, back to maybe someone sane like Farnell, or any chance we get radionics, any chance they might have it. No. Let's just go straight to Mother. Let's go straight to Mother. Oh my god, come on. No, that's a Molex part. Yeah, 'cause that's really what I looked for. DigiKey. Come on, DigiKey. Why? Hang on, what's going on? This is BM50B. Why is it not? What's going on here? I think my copy and paste function is a little bit screwed here, guys. Yeah, it's not actually copying and pasting for me, so that's very helpful. Let's try this. BM50B minus S or DS minus A minus G minus TF. Enter. Once again, perhaps DigiKey might have it. Oh my god, it is a miracle. It is an absolute miracle. DigiKey have this freaking thing. And they are $296 each. So we have 270 of the little freaking things in stock. even though that picture does not inspire confidence. That picture is not inspiring confidence, guys. You just grab the data sheet here one more time, and it is the wrong connector, I think. I think somehow we've ended up with the wrong connector, and this is an SHD. Yep, it's an SHD. What the heck, guys? SHLD is the one we want. How do I get them screwed up like this? What's going on? What's going on here? I think I'm getting lost here somehow. SHLES, yeah. That's the one we actually want. How's my pointless live stream going? Very well, actually. There's absolutely nobody watching. This is my best one yet. Let's try arrow again, because they were the closest that someone actually might have had. That's the wrong part again, even. BM50B. SHL. SGTFT. Okay, so it looks like they say they're 530 of them. So let me enter, I don't know, 2 by that. Let me guess, there's been an error. Of course there has. Oh, this is insane. Okay, the side entry is SM50B, and the top entry is this one, shrouded header. Shrouded header. So this is definitely our one, is the SHLB. Alright. I think I need some water.
It's great that there's no one on this to tell me if it's broadcasting okay or whether I'm completely just wasting my time, but hey. That's what I'm here for, guys. I'm here to waste my time for you. Alright. I'll get my jumper. A little bit cold, I think. Alright, now. So the SM. Yes. SM is the side mount. Let me just check a few basics here. The B dimension is the outer side, which should be 28 millimeters. Let me just grab the vernier and just make sure I'm not completely barking down a wrong tree here. Barking up a wrong tree, Damien. Yes. Yeah, 28, bang on. Alright, that's looking pretty good. I mean, I know it's just a basic check. What I need now is still trying to find someone that stocks this piece of junk. Because getting that off the board is absolutely not an option, let me tell you that. Oh, yeah, why does it do that? Looks for the wrong part for me. That's very helpful. That's not
You know, so they're not what I want, guys. Okay. So I'm looking like basically nobody has this thing. If I go to DigiKey, even I don't think they have it. Or they do list it, but I think they don't. No, they actually don't even list this part. No, they don't even list it. It's a wrong one. I really get lost in these things. And if we gotta try the side entry one, like I say, that would work for us. That would work for us in a pinch. Yeah, they list the side mount one. €1.73. Not in stock until I have to buy 1,000 of them. So that's helpful. Great. Yeah. So, not a good sign, sports fans. Not a good sign. Getting this connector now could be a real problem. Yeah, that's not going to help me, is it? Well, in a UK office, JST help, but that'll be the usual minimum order quantities and stuff like that. It's not really going to help us. Yeah, we're kind of screwed here now. Alright, I probably bored the people that aren't watching this video to death too much, so I'm going to go back to reverse engineering. Finding that part is going to be a problem for us, that's for darn sure. I would not rate my chances removing that intact and putting it on another board intact. We may have to try anyway, particularly if this turns out to be some kind of unobtainium crap. So that's great. Wonderful start to our project. Anyway, let's, for the sake of fun and games, reconnect here. And we'll go have a look at some of these guys. Now, I kind of under the impression, it might be an erroneous impression, that these are current sensors. Now, there's a total of, basically what I've got in here. So I have 1, 2, 3, 4, 5, 6, 7 wires into an 8-way JST connector that we can get, so that's kind of handy. I'm just going to do the MG2 one here now. I'm going to probe it and see what it does for me. So let's go to 20 volts. Power on, power on. Alright, so looking at current sensors. Current sense, I'm going to say MG2. I just call them current sensors, they may not be. So white, blue, white, blue, brown, white, blue, brown, black, and yellow.
Then there's a space. There's a space. And then there's a green and a red. Green and a red. I'm going to do something first. I'm going to go back to the continuity beeper and just beep to ground. See if any of these are just plain old grounds. White isn't. Blue isn't. Brown isn't. Black is. Is it? No, it's not. It's a liar. Yellow isn't. Green isn't. And red isn't. So, black could be a ground. It kind of beeps a bit weird though, so I don't quite trust them. Go back to 20 volts. Turn on the power. So the white wire giving me 4.9 volts. Blue wire minus 5 volts. This is relative to ground now, so it's a bit weird. Brown wire, 4.9 volts. Black wire, 5 volts. Yellow wire, 4.9 volts. Green wire, 4.9 volts. And finally the red wire. Ooh, how was that? $26 volts. Oh, that's fun. Now this is relative to ground. Okay, let me see if the MG1 does the same thing. Let's go on the red wire, 26 volts. White wire, 4.9 volts. Okay, so I'm going to say they're probably both the same. So if we figure one of them out, we should figure them all out. Now, this is weird though, because although I'm measuring these, none of these are directly related to ground from what I can tell. So let's turn off our power supply. Go back to beeper. I'm going to unplug the actual cable here. I'm going to go around here, see if any of these relate to ground without the sensor or whatever it is connected in there. And they don't, which is interesting. Because what that could mean is that we have separate grounds here. These may not be isolated current sensors. So next thing we're going to find out, if we're going to actually physically have a look at it. They look a lot like Hall effect current sensors to me though. Kind of the copper bars going through them. I don't really see anything in there that's, you know, it doesn't look like one of the Melexis type that are actually soldered to the, or, you know, bonded to the copper in some way. I don't think so. There's some strange artistry going on here, guys. Or nobody. Yes, nobody's. There's some strange artistry going on here. Look at all this stuff you're missing, guys. All this fun you're missing. Me getting frustrated and everything else. You're missing all this. But it's great. And I've got full stream health. It's green for go here. You know, it's really good. Oh, it's a good test. If nothing else, it's proving to be a good test. Alright. Let me see. This is interesting, to say the least of it. Now, give me my beeper. No. My own beeper? No, your own beeper on it. Now, there's kind of a ground planey type thing here. But
Okay, all these caps, grounds on all these caps, I'm going to check that they are grounds. Looking for one that's not. Oh yeah, there's one that's not. There's another one that's not. Interesting. These two are. Yeah, this little turkey isn't. You're separate, aren't you? Yeah, you have separation. Separation sequencer. So, let's have a little bit of fun here now. Because what I would like to do, this is going to be the best of the probe. Let's say it is. Yeah. Bingo. Our blue wire is on this because this is, of course, this is the negative 5 volts. This would be the negative 5 volt capacitor. Yeah, of course it would be. Yeah, okay. So therefore, then, if that's negative 5, this would be grounded. Yeah. Okay. Okay. This one is not though. This one is not. That one is. This one isn't. It's not connected anywhere. Okay. So he's a little bit of a separate guy then. So we're not getting a really good connection on that. Again, another pointy probe. Another pointy probe. Pointy probe, pointy probe, pointy probe. Yes, pointless live stream. Welcome to your pointless live stream. I will be your host today. Mr. Pointless. Here we go. There's a fairly sharp probe. Okay, 2 pointy probes. Okay, 2 pointy probes. So now I can go on that wire. Now I can just go and probe on here. Okay, nada. Curious. Okay, so something like this. It's a little bit of a mystery. It's actually quite interesting. So let me grab my magnifier and we'll go back to work on it. And at least it could if my magnifier wasn't gone completely crazy on me. What's the matter with it now? It's gone completely crazy on me. Oh, there we go. Yay, okay, figured it out. So, black wire and the blue wire are connected to a couple of stitched vias on there. So black and blue, black is 5 volts and blue is minus 5 volts. So that makes a lot of sense. Something connects somewhere. Now there's a little, I think one thing our friends here are quite good at is using ASICs. Unfortunately, of course, we won't be able to get any information on those. It's unlikely.
Now, allowing for the fact that there's 2 current sensors on each one of these, and okay, so there's 2 current sensors. It looks like some of the wires are moved around a bit. Like there's 5 wires, and then there's 2 wires. A total of 7. Which is a kind of a strange thing. Two sets into these 2 plugs here. Now, of course, there's one other little thing that I could be getting fooled about here. Is they may not be just DC signals. Let's see if they exhibit any anything interesting. So we'll hit them with the oscilloscope and see what they have to say. Just for old time's sake. No, oscilloscoping. White wire, it's a DC signal. Blue wire is a DC signal. Brown is DC. Black is DC. Yellow is DC. Green is DC. I'm guessing this one's shot off the screen because it's yeah, it's a DC signal. They're all DC signals. So there's nothing, there's nothing weird going on there too much, Just probing around some of these inductors just for a gas as well, just to see if they're switching, or if they're part of the power supply. There's definitely a whining going on here. Okay. Alright, just wanted to see if there's anything weird going on with those signals. I have been fooled by current sensors, as any of my major fans who are tuned into this live stream will know about. So yeah, this is a mystery, the mystery of the current sensors. Help me solve the mystery of the current sensors and you could win a prize. Alright. Time for lunch.